Hi, this is Leite, and in this video I'll demonstrate automated measurement invariance testing in Mplus. I will run a demonstration based on this article here, the stability of elementary school contexts for kindergarten to third grade. I will be fitting confirmatory factor analysis models and doing variance tests based on constructs in this table. First, I will do a confirmatory factor analysis and measurement invariance testing for school safety practices and school violence and crime, because those are binary measures. I could do all of these at once. There are categorical measures here, but to simplify the example, I'll first do measurement invariance testing just for the binary measures. So I have here the Mplus code for the binary measures, and this is data from the early childhood longitudinal study, and we have three groups. It's a school level analysis with three groups: kindergarten, first grade, and third grade. Now, the grouping variable here is used to declare the variable that contains the group information. So in this case, the variable is grade, and 0 means kindergarten, 1 first grade, 3 third grade. These variables are categorical, as I declare here. They're actually binary. And missing value is coded as -99. I will use the weighted least squares with adjusted means and variances, WLSMV estimator, which is default for categorical data in Mplus. Now with this line here, I request the automated invariance tests. So I will run a configurable model which allows factor loadings and thresholds to be different across groups, and a scalar model which constrains the factor loaders and thresholds to be equal across groups. So Mplus will automatically do a chi-square difference test for me. The model here has two factors: safety, measured by these indicators, and crime, which is measured by these indicators. So we'll run this model. Here I'm running Mplus 8.8, and I'll scroll down. These are the sample sizes for each group, so it's fitting a multiple group confirmatory factor analysis. And I'll scroll down past the descriptive statistics, and the first thing here I have is model fit information, and the first part of model fit information is invariance testing. So I have the chi-square for the configurable model, the chi-square for the scalar model, and then a chi-square difference test, which shows that the chi-square difference is 13.745, the difference in degrees of freedom is 10, and the p-value is 0.1849, which is not statistically significant, indicating that the simpler model, which is a scalar model with constraints on thresholds and factor loadings, fits as well as the configurable model, which does not have any constraints. Therefore, we conclude that there is a scalar invariance. So the factor loadings and thresholds, they are invariant across the three grades, first, third, and fifth. And because these are binary measures, the threshold is related to item difficulty in item response theory, and the factor load is related to our item discrimination. So here we can also conclude that in an IRT framework, that discriminations and difficulties are the same across groups. Okay, we have here the chi-square for each group, the chi-square contribution, and then Mplus presents first presents model fit information for the configural model, and the model fit information for the scalar model. You can see here that that based on the root mean squared error is 0.024, CFI is 0.978, and TLI is 0.972, so there is close fit of the scalar model. And then Mplus shows the results for the configural model, and the scalar model. And the scalar model, as you can tell, the constraints were put, for example, the first factor loading for safety is for kindergarten is 0.557, and you can see it's the same value for first grade and third grade here. Okay, so that is how you perform an automated invariance testing for binary measure. Now I'm going to show you with same automated test for measures with 5 categories. Okay, so also from Lowenstein here we have some measures with 5 categories. So for example, school strain has 5 categories, and I will first positive school climate also has 5 categories. Okay, so I will run first invariance testing treating these variables as categorical, which is preferable. So I have code here where I'm using, declaring the grouping variable as grade of 0 equals kindergarten, 1 first grade, 3 is third grade. The variables are treated as categorical. Now my model here, I am requesting configural and scalar invariance models, and I have the latent variables as school strain with 4 indicators and positive school climate with 4 indicators as well. So I'll run this, scroll down, first we have descriptives here, and I have here invariance testing, where the chi-square for the configural model, chi-square for the scalar model, and then the chi-square difference test. And you can see the p-value is 0.079, which is not statistically significant. Therefore, the scalar invariance model fits as well as the configural invariance model, which leads us to conclude that thresholds and factor loadings are equal across groups. Okay, and in this case, we have here model fit for the configural model, model fit for the scalar model. You can see that there is close fit. The mean squared error is 0.065. CFI and TLI is 0.95 and 0.96. And then we have the results for the configural model and the parameter estimates for the scalar model, and which constrain the factor loadings to be the same. So for example, for first factor loading is 0.74 for all groups, also 0.74 for first grade, 0.74 for third grade. And you can see the variables have 5 categories, so they have 4 thresholds. Here are the thresholds, and you can see that the thresholds are the same for cross groups. So first threshold is minus 0.327, and you can see it's the same value for the other groups as well. So this is with 5 categories treating the variables as categorical. Now note that Mplus only allowed me to test for configural and scalar invariance, but not metric, because the variables are categorical, so the metric invariance with the delta parameterization Mplus would not be identified. However, I will do a simplification now where I will treat these items with 5-point Likert scales as continuous. So this is the last one where I'll treat them as continuous. And you can see here I remove the categorical R statement. Same groups, but now the estimator is robust maximum likelihood, and I have model configural, metric, and scalar, and the same factors, climate and strain. So I'll run this. Now because I'm treating the 5-point Likert scale as items as continuous, I no longer have thresholds, I have intercepts. So the parameters are factor loadings, intercepts, and residual variances. You can see here the model fit. The first thing you get is invariance testing. It shows the chi-square for each model, and it shows the comparison. Notes that comparing metric invariance is only the factor loadings are constrained across groups, against configural, which is no constraints, results in not significant chi-square test, indicating that the metric invariance model fits as well as the configural invariance model. Now, and then we see that the scalar invariance model fits as well as the configural invariance model, but the scalar invariance model fits worse than the metric model. Now, we should be doing this in a sequence, so metric against configural, and then once metric holds, which is with this line, metric invariance holds, we should do scalar against the metric, which does not hold. So metric fits better than scalar, therefore we'll consider here that metric invariance holds. And the results are shown. Now note that I'm treating the items as continuous, and that does much worse in terms of model fit. You can see here that the model fit is not acceptable, like the CFI is 0.88 and TLI 0.81, and that was a consequence of treating these categorical variables as continuous. Okay, that's how you run automated invariance testing in Mplus.